Right, Assalamualaikum, selamat pagi. Okay, I hope that everybody was in. Let's start with our class. Okay, before we start, I have two things to share first. So the first one, let's take a look here. Your scheme of work. Alright, this week is your week of 10. Okay, minggu ke-10. We already covered angular kinetics. And today we are going to cover the fluid mechanics. Okay, so minggu ke-10 kita cepat seminggu lah. And minggu hadapan, minggu 11 is your 11th week where you are going to have your test 1. Okay, and test 1 will cover, tak tulis kat sini. So most of the time test 1 will cover up until here. Dia akan cover 6, 1 sampai 6. Okay, sampai talks. Okay, it will cover up until torques, and angular kinematics onwards will be covered on test 2. But if there are changes, I'm going to let you know later lah. Okay, I hope that there are no changes. So if everything according to plan, your test 1 will cover up until chapter talk. Okay, that is the first one. Second one is about your group presentation and report. Okay, ni assignment kedua kamu. Group assignment, presentation, and also report. Alright, so here what you need to conduct, what you need to do is actually conducting a spot skill analysis by using two-dimensional methods. So two-dimensional methods ni benda yang paling common sekali is actually by using a software known as Kinovia lah. Kinovia. Okay, datang ni. This is the most common 2D analysis instrument. So you may have it from here, okay, kinovia.org ni, ataupun you just type kinovia.com and download the latest one, 0.9.5. So it will give you a software where you can make some analysis, kinematic and kinetics. Most of it is kinematic, by using only a two-dimensional video. Okay, a two-dimensional video. Alright, so from the assignment, what you need to have is you are going to have a 4-section assignment where the first section is about the introduction of the skill, where you need to introduce the skill itself. Okay, apa benda yang kamu buat. Let's say you take soccer. Okay, so you take free kick in soccer. Based on the spot, just choose a skill, one skill. You take you take soccer, and then at the first section, you need to introduce about the skill, movement of the skill, how we propose a free kick, how we conduct a free kick. And then based on that, you need to talk about the muscles involved, the bone involved in the execution. Task analysis ni movement performance criteria is parameters of the action, form of motion. You need to talk about mechanical basis and anatomical basis of human motion, where you observe the skill, frontal ke, sagittal ke, what kind of skill, flexion, extension, hyperflexion, all of those need to be explained in the first section. Okay, and towards the end of the first section, in your presentation you need to have video lah, but in your report you may have a segmented frame of action. So daripada dia punya setup sampailah dia punya follow through. That will be the first part. Okay, the second part of the presentation and report, the second section is about kinematic and kinetic analysis. Okay, kinematic and kinetic analysis is based on what we have learned before. For example, kinematic, we have acceleration, we have velocity, we have displacement, both angular and linear. Same goes in kinetics, where you have 3 different methods of analyzing, such as the impulse momentum methods, the F equals to ma method, and also the work, power, and energy methods. All of those we have learned during earlier week. Tu benda tu kamu kena cerita dekat dalam kinematic and kinetic analysis. For example, you choose free kick, and the purpose of analysis, you want to see the kinematic action of the free kick. How about the displacement of the feet, the velocity of the hip region and the acceleration, and the relationship between those acceleration with the acceleration of the ball itself. Benda tu kamu kena cerita lah. How much force is needed, how much work being done, all those that we have learned before. Okay, so you are going to conduct you need to explain about the purpose, you need to set up the video recording and analysis, and then you need to explain about the kinematic properties and kinetic properties that you may have from the video. Okay, you may have from the video. For example, your video is more prone to acceleration, so you talk about that more. Tengok, kamu punya objektif lah. Okay, and finally, on the third section, you need to explain some step that you may have to maximize skill performance. Okay, to maximize skill performance means based on the kinetic and kinematic, based on the principle of force summation, based on anything, the modification of technique, how can you further modify or further increase the performance of your athletes. Let's say free kick tadi, how can you have much accurate free kick? How can you increase the speed of the free kick? All of that need to be having in the third section. And finally, conclusion lah. Conclude what you have done. Okay, this is some special instruction for the presentation. Okay, the duration of the recorded video presentation is around 15 minutes. Okay, so the most of your presentation can be up until 45. That's all. Don't exceed that. Kalau kamu exceed tu, either you start bullshitting everything inside that, or you just read everything. So try to present in 15 to 45 minutes. Okay, here they put it as 4% per group, but I'm going to permit you to do up until 5. Okay, and then you need to use Kinovia. Okay, you need to use Kinovia. Video of the sample need to be from online, YouTube, Facebook, or okay, it's even better if you can actually record your own presentation. Some of your friends perform and you record pun boleh, tak ada masalah. Okay, and all those report and recorded video presentation are to be submitted by week 13. Okay, yang ini kita ada sedikit perubahan lah, because if we take a look here at the scheme of work, you may actually submit everything on week 14. Ni. Okay, week 14 ni video recorded group presentation and written report to be submitted. So, I already postpone the date of presentation to week 14. Okay, now we are at week 4. So, kamu ada 1, 2, 3, 4. Roughly 5 weeks to conduct the presentation, record, and submit. So, your recorded presentation need to be uploaded in YouTube and then post the link in the attachment later. Saya tak nak kamu masukkan the whole video dekat dalam Google Drive tu. Okay, we have some limitation now. So you need to upload that anywhere on the web and then just attach the link to the video. Okay, that will be regarding the presentation. Okay, jap kita tengok ada tak dia punya mana? Is there any rubrics? Okay. Sekejap ya, saya akan tunjukkan rubrics dia. Okay, so these are the rubrics for your group presentation. I'm going to attach this rubric later. So, kalau dia tak dapat ke apa, jangan risau. Ini untuk kamu tengok sekejap saja. I will attach that later. Okay, these are the rubrics for your group presentation. Kamu ada intro. Ini selalu orang lupa. So, make sure you report this in your report and also in your presentation. Methods of recording. How you record video. What are the equipment used to record the video? Okay, critical observation. This one is about how many observation you conducted. For example, you explain about force, that is one. You explain about acceleration, that is 2. To have the most mark, you need to explain critically more than 3 observation regarding the skill itself. Okay, and then you need to discuss all those observation, and finally presentation and reference. Okay, ini pun selalu orang lupa, referencing. You are now at semester 5, supposedly all of your presentation now, all of your report need to have a page of reference. From where you get the information, what is the sources that you use, all of that need to be fully documented. Ini untuk memudahkan kamu buat research nanti. Alright, so these are the group presentation and also the whereabouts of us, okay, in week 10. Okay, any question on that? If you don't have any question, we are going to start with our topic for today. Ada soalan tak sebelum kita mula dengan topik ini?
So far, okay, sir.
Okay, alright. Okay, so today topic is a continuation of our topic last week. Okay, last week kita belajar tentang impulse. Okay, angular impulse, angular kinetics, angular momentum, angular impulse, and also what we call it, moment of inertia. So today topic is the continuation for kinetics. Okay, and it's about motion in fluid, pergerakan di dalam benda lir. So when we talk about fluid here, we in Earth is actually in fluid condition, because fluid can be divided into two. The first one is sekejap sekejap. Okay, when we talk about fluid in our life, fluid ni kita boleh bagi pada dua. We can divide into two. One, fluid yang semua orang bayangkan. Fluid is the fluid, water. And number two is air. So air is a form of fluid. Cuma if we compare the density between air and water, air will be much less dense compared to water. Okay. Other than that, those two is fluid. Right. So what is a fluid? It can be described or defined as a substance that flow or continuously deform when subjected to shear stress. Means it can change shape accordingly to the shape, encompass shape, according to the bekas. So if you are in your room, the fluid is in the shape of the room. If you go outside, the fluid is accordingly to the surrounding. Tu fluid, benda yang berubah bentuk, substance that continuously deform. So both liquid and gases are fluid with a different density. Okay, so air and water are fluid that commonly exert force on the human body. Jadi kita memang bergerak dalam fluid lah. So part of the force that actually have in the what we call it in our earth is actually friction, and this friction is caused by the density of the fluid, and that is the reason why if we're running on track and suddenly we go in water, we are going to feel a bit of increment in terms of resistance. Tadi kita ada resistance gases saja, but now you have resistance of liquid, which is much denser, and it will give you more resistance to give friction and resistance. Okay, so when we talk about fluids, the most properties that have a direct relation with fluid is velocity, had laju. Okay, before this, when we talk about velocity, we only calculate without the inclusion of fluid. So bila kita include fluid, we are going to have a relative velocity. Okay, so it can be defined as velocity of a body with respect to the velocity of something else. Okay, contoh dia macam ni. Okay, the thing that being that being affected is actually the amount of force being delivered by you. For example, if you are running or if you are cycling towards a headwind, means angin daripada depan, you are going to feel a bit hard to pedal. Okay, you are going to feel a bit hard to pedal. Siapa ni? Nur Anastasia, ada soalan? Anastasia.
Tak ada, tertekan.
Aduh, jangan tekan. Dah angkat tangan kena tanya soalan. Any question? Okay. So yang first ni kan, the velocity of cyclist relative to wind means that the force that being given by the cyclist is actually to produce a 20 meter per second of velocity. However, since they are headwind, the cyclist velocity now just become 15 meter per second instead of 20. Okay, kalau kita terjemahkan dekat dalam pengiraan, it will become something like this. Okay, kita akan ada. Okay, if you take a look here, so we have velocity equals to velocity cycle minus velocity wind. Ni velocity total lah ataupun kita panggil net. Okay. So, velocity net here, it depends whether you are having a tailwind ataupun a headwind. It depends on where you are cycling. If you are cycling that way, wind from forward is known as headwind. Means that the wind that oppose the direction of your cycling. If the wind is in the same direction of your cycling, it is known as tailwind. Okay, kalau kita ada basikal pula, kita kayu ke sana. The wind come in opposite direction. This is known as headwind. Okay, so opposite direction to the direction of the bike being cycled, this is known as head. The same direction of wind with the same direction of the bike being cycled, it is known as tailwind. Okay, so kita kena tahu direction of movement first. Okay, let's say direction of movement dia macam ni. And this one move at 20 meter per second. So your velocity of cycle is 20 meter per second. And then you meet a headwind of 8 meter per second. When we meet a headwind, we are going to minus that. So it become 8 meter per second. The total is only 12 meter per second. Means if you have a headwind, you are going to lose velocity because some of the velocity is needed in order to overcome this headwind. Okay, and in case of tailwind, we need the same one, 20 meter per second. However, the tailwind here is let's say 5 meter per second. When we see tailwind, it helps if the direction, if the direction of friction is in the same direction of the force being applied, it helps. Okay, meaning that it will reduce your effort. Jadi kalau kita masih guna kelajuan yang sama, if you face the same one, it become tambah. Okay, dia akan jadi sama, nampak? Depan tambah, belakang pun tambah. Kalau kita bertentangan, depan is tambah, belakang is tolak. Change of direction. So now, although you are cycling at 20 meter per second of effort, with a help of 8 meter per second tailwind, you are going to end up 28 meter per second in total velocity of the system. Ni kebaikan dan keburukan fluid lah. Okay. So this is what headwind and tailwind give effect to the effort of the cycling. Ini yang pertama, nature of fluid. And this is actually friction, restriction. Okay, this is a friction. This is, ni bukan lagi friction. Okay, so kena tengok arah mana. And this is the reason why sometimes you cycle, you feel quite hard, but in other time, in other route, you feel that, oh, this route is much easier because that route tend to have more tailwind compared to headwind. Okay, yang pertama. Alright, and then when we talk about fluids, the most important thing that you need to know is actually the type of flow, because the type of flow determine the amount of effort needed. So in nature of fluid, we have two type of flow. The first one is known as laminar flow. The second one is known as turbulent flow. Okay, laminar dengan turbulent. Laminar dengan turbulent. Okay, nampak ni dulu. Laminar dengan turbulent. Alright. So laminar flow is being characterized by smooth parallel layer of fluid. Ni di chain, while turbulent flow is being characterized by mixing of adjacent fluid layers. Okay, tengok ni, towards the end, the fluid layers being mixed, top and bottom. Yang ini, towards the end, kita tak tahu, dia tak tunjuk. Okay, so concept of laminar and turbulent flow is actually the concept of mixing and parallel fluid layer. So if we take two shape, okay, satu kita ambil shape yang macam ni, aerodynamic shape. Satu lagi kita ambil shape yang macam ni, quite a box shape. Okay, this is the direction of wind. Okay, direction of wind. If we go in a wind tunnel and we do some some testing on these two shape, both will actually have quite a laminar flow in the beginning. Okay, kamu akan dapat laminar flow. And, oh sorry. Okay, cerita dia is towards the end, towards this region. Okay, with much aerodynamic contour of object, towards the end, okay, this is if the velocity of speed, kita panggil velocity at the up and tak best up, we call it at top. Okay, velocity top and velocity bottom. If these two velocity is equal, you are going to have a mixing of air at the ends. Okay, you are going to see a mixing of air at the end if the velocity of these two part is equal. Tapi if we compare these two shape, mixing dekat bahagian belakang kotak ni akan jadi lebih besar. Okay, dia akan jadi lebih besar compare to mixing dekat bahagian belakang aerodynamic. Ni mixing up, and you are going to notice if we change shape, itulah sini, when the air being pushed through the shape, it will actually wrap the shape around regardless of the shape. Benda ni memang akan terjadi. Okay, unless we reduce the thickness of the shape. Means that kalau benda tu nipis, this wrapping effect is lesser compared to dengan if benda tu tebal. So if benda tu tebal, you are going to see a clear, okay, a capsuling effect. And towards the end, it going to be mixing up. Jadi untuk kurangkan mix up ni, we need to have much thinner, okay, ataupun bentuk ujung yang lebih tirus. Okay. So this capsuling or encapsulating effect is known as Coanda effect. Ni effect yang capsuling. Okay. Which resulting towards the front end of most of the object, you are going to have laminar flow, and towards the end, you are going to have turbulent flow. And in between these two, ni bahagian ni, you are going to have Coanda effect. Okay. Meaning here, what I try to show you is, we are going to have those two type of turbulent regardless of shape. Okay, we are going to have laminar flow, we are going to have turbulent flow regardless of shape. Cuma, if you want something that is sound, means perfect in term of movement, try to be more laminar. But if you try to make an object which the function is actually to slow you down, like a parachute or something, you need to have a lot of turbulence so that it can catch up air and stop you. So to determine whether that object is laminar or turbulent, we are going to consult a coefficient, okay, and it is known as Reynolds numbers. And Reynolds numbers is actually dimensionless, means there are no exact stop on the numbers. Okay, there are no exact stop. Dimensionless number in fluid mechanics. So what Reynolds number give you is, they are going to give you numbers in something like this. If the numbers is less than 2300, okay, 2300, 2300 or 2300, if the numbers is less than this, we can see that the item is aerodynamic, means it has less and less, very less turbulence. But if you got, if you put an object in wind tunnel and the numbers tend to be more than 4000, means that the object is more prone to turbulent rather than laminar. And we have an object that being put in between those two. Itu kita panggil sebagai transient object lah. Means that it has both equal value of laminar and also turbulent. Maksudnya dia tak berapa aerodynamic and also it cause a lot of turbulence. Ni especially in sport engineering. Okay, this is especially in sport engineering. Okay, when we talk about do I have sharing with you a video on the fastest bike in the world? Dia kayu basikal sampai beratus-ratus kilometer. Ada tak dia? Pernah tak saya sharekan video itu dengan kamu? A cyclist cycle their bike towards an extreme figures. Ada ke tak ada?
Tak ada, sir.
Okay, sekejap Okay, let's watch this one. Sekejap ya.
Trade with the world's #1 broker, FX Pro, 2,100 plus instruments.
Mandian Dettol Gentle Care dengan wangian habatus sauda dan melati putih memberikan kelembapan selama 8 jam.
We are going to observe two videos. This one is the first one, and this one will be the second one. These two we are going to put a cyclist behind here. Okay, behind here. This is a concept of laminar and turbulent. And when if you see this contraption di belakang ni kan, kalau saya pindahkan dia kepada gambar rajah lain. Okay, kita tengok belakang tadi tu, we have a box. Okay, and then kita ada area, something like that. Okay, ni kalau kita tengok pada belakang lah. Kalau kita tengok pada tepi, you are going to see something like this Ni kereta. Bicycle will be put behind here. So what this car, what the contraption done is actually, they are going to deflect the air. Okay, they are going to deflect the air. Means you are going to have turbulence far behind. And when this happen, there will be an area behind the car which we can see it is in a state of vacuum. Means there are no visible air in that area. So if you put, let's say, 100 Newton in pedaling, this 100 Newton will be translated in velocity. Kalau kita kayuh basikal saja-saja, macam biasa, kat tepi-tepi jalan macam biasa, you put 100 Newton of cycling, yes, you are going to get velocity. At the same time, there will be headwind, which will reduce your velocity. Katalah tadi 1 Newton boleh bawa 1 meter per second. So 100 Newton, supposedly your velocity now is 100 meter per second. But you have headwind of, let's say, 35 meter per second. So you end up dengan V equals to 65 meter per second sahaja. But not in this case, where you actually use 100 meter per second and you use everything to pedal you forward, because there are an area without any friction because of all those lamina, all those turbulent, all those air is being put behind and outside of the area itself, which means that you are going to get an area without resistance. Okay, so kita sambung video ni. Okay, now he already pedaled at 112 km per hour. Okay, try to observe when the biker is quite far behind, you are going to see that he start to wobble. Tengok yang tu cuba dia sekejap-sekejap je yang tu. And then you can actually observe there are certain time this cyclist does not pedal at all. Okay, they stop pedaling, yet dia tak tertinggal kat belakang, but you can actually see the bike being pushed forward towards the car. Itu adalah benda ini. Okay, that is this thing. Ni, bila dia termasuk dalam kawasan turbulent, all of this turbulent, dia ada the turbulent is work something like this. Dia punya perjalanan dia akan macam tu. So these are the direction of the air actually. The turbulent is caused by mixing up of the air. So we can see that there are area that actually push the cyclist ke depan. Okay, it push them. But if you go too much in depth, you're going to get to push backwards, and this is where they start to wobble. Satu kamu nampak kadang-kadang dia tak kayuh, tapi basikal dia ke depan, kereta tak brake. Okay, dalam posisi sekarang, if the car slam on brake, dia dah tak boleh buat apa dah. Basikal tu bukan direka untuk brake pada kelajuan begitu. So now let's see the final push. Okay, that is the wobble because he is in the turbulent area. And when the bikers is out of the turbulent area, dia dah tak boleh nak kejar lagi dah kereta dekat depan tu. Because there are no pushing force. Okay, dah tak ada tailwind yang push dia ke depan. So now he only subjected to headwind, which is actually a lot of resistance at that speed. Ini adalah one of the concept for lamina and turbulent. Okay, now let's see the second one. This one is purely regarding friction and air friction. Okay, ni lagi laju daripada tadi. Okay, so this one is an attempt to go downhill with a bike. Okay, where he is going to wear.
Tak nampak.
Tak nampak? Oh, sorry. Okay, this is another attempt going downhill. Okay, tadi kayuh. Yang ni dia go downhill. It means they try to reduce the air friction as most as possible and at the same time to have much lamina flow rather than turbulent so that they have less resistance and can achieve the greatest speeds downhill. Ni lamina. Tengok baju dia pun dah nampak. Dia cuba kurangkan lamina. Cuba kurangkan turbulent. Okay. In order to kurangkan turbulent, in order to kurangkan this effect, ni kan tadi yang kita tengok ni. Ni. Coanda effect ni is by having something thin. Okay, macam tu. Jadi lagi kecil dia punya belakang, lagi kurang turbulence yang dia ada. Means the flow is going to be lamina. Okay, coanda ni pula, coanda effect ni. Okay, pernah tak macam ni? Pernah tak kamu where is my slide? Okay. Kalau kamu kata kamu ada botol air ke ataupun botol air yang panjang ke kan, pernah tak kamu ataupun cawan kan, kadang-kadang kita tuang air dan cawan nak pindah ke cawan sebelah. Bila kita nak tuang ke cawan sebelah, dia bukan keluar zwet macam tu ke bawah tak, tapi dia melilih dekat tepi cawan je dah bersepah kat bawah. Pernah tak kena benda macam tu? That is coanda effect. That is coanda effect. Ataupun lagi satu, if you want to try coanda effect, okay, kamu ambil botol macam ni kan, kamu nyalakan satu lilin kat belakang ni and try to blow. Blow through the bottle. You are going to notice that the lilin is going to padam. Okay, it's going to light off the lilin. The candle will be light off. Walaupun dia duduk dekat belakang botol. Okay, jadi dengan botol kan, letak lilin tu dekat belakang sini and then you blow from this side. You blow from the other side. Macam tu nampak botol. Okay. Sekejap. Mana saya punya visual effect. So let's stop the visual effect. Okay. Let's stop the visual effect for a while. Okay. Botol, lilin. Put lilin belakang botol, put botol depan lilin and tiup. You are going to notice the lilin is going to padam. Because when you blow, the air, kita mungkin bayangkan the air go to the bottle and deflect. It deflect. No. But based on coanda effect, if you blow an object, especially a round object, okay, what the air will do is actually dia akan curve around and go forward. Curve around and go forward. It is because of pressure. Okay, it is because of pressure within the particle of air. Dia tak pergi bersepah. Instead, the pressure that push the air towards the surface of the object is greater than the pressure that push it out away from the surface. And benda tu akan menghasilkan encompassing effect. Ini coanda effect. Okay, this is what we call as coanda effect. So towards the end of coanda effect, if the velocity from this side and from that side is equal, they are going to mix up. Itu kita dapat turbulence. Okay, that is the reason of the presence of turbulence. So if the shape is smooth, the turbulence is less. If the shape is small, the turbulence is less. If the shape is big, you're going to get a lot of turbulence. Okay, so itu adalah coanda effect. Sekejap saya tengok kalau saya ada video yang ada kaitan dengan coanda effect. We can actually observe that. Sekejap ya.
Wind, show me where to go.
Terlajak perahu. Okay, so let's see one of the example. What is Coanda effect? Okay, here. Okay, dia akan blow air dryer ni ke atas sesuatu and you're going to see the air start to wrapping.
Closer and closer, you see the flow of air is straight, but when it is close to the object itself,
Okay, now you can see the air deflected. Okay, the air start to deflect downwards sampai sini. Jadi kalau angin ni ada daripada atas, ada daripada bawah, when these two direction meet, kat sini kita akan dapat turbulent. Okay, ini masih lagi lamina lah.
the air gets deflected downward.
Okay, you can see all those cloud of air, tu semua turbulent.
It follows the contour of the cylindrical object.
Okay, lagi satu yang kita boleh nampak Coanda ni. Sekejap. Okay, this one.
Hair dryer.
There. Okay, saya nak kamu observe 2-3 benda. Satu, the effect of Coanda. We can see wrapping. 2, the airflow. Okay, this one is lamina airflow. Dekat belakang ni kalau tengok dia tak banyak lah, but you can see some mixing up, that is turbulent. And turbulent airflow
Notice
cause
as
the wobble.
I tilt the hair dryer,
Nampak agak
the
sikit-sikit.
ball remains in the stream of air and is still levitated. But also notice how the bottom of the ball is deflecting the air so it wraps around. The air follows the contour of the shape of the ball.
Okay, so these are the cause of wobble, the cause of resistance, and later on this is actually the cause of flying, terbang. Okay, so kita tengok yang tadi balik. Okay, so dia kalau kita tengok dekat sini kan, dia cuba untuk kurangkan gapping yang selagi yang boleh gap tu, so that dia akan dapat satu smooth aerodynamic. Okay, satu smooth shape. Means kalau kita buat wind, kita masukkan angin tadi, kita akan dapat tengok wrapping shape and then much lamina shape dekat sini. You are going to get some turbulence at the end of all those creases, tapi turbulence dia taklah sebesar turbulence basikal biasa and normal cycling position compared to this one.
Record battu.
km/h, even faster than car actually. Tapi Yang itu boleh dilakukan dengan flow yang paling minimum. Okay, saya tunjuk satu lagi contoh. Sekejap ya. Correct. Okay, tak jumpa. Saya jumpa video ni, saya tunjukkan pada kamu. They compare a minivan with sports car. Cuma sports car model lama where the shape is quite boxy, and when they do the comparison, they end up that the sports car actually have a larger number of Reynolds compared to the minivan, which make the minivan much aerodynamic. Pasal bentuk je, okay? Not the size but the shape determine whether it is going to be a laminar, a transient, or much more towards the turbulent numbers. Ni untuk flow, okay? Arah angin. So if we play sports, let's say downhill, okay, we go for downhill snowboard. How we can actually reduce the time of downhill, macam mana? So we play around with all of this. Fluid in motion, motion in fluid. Macam mana kita kena tunduk, kita kena reduce the friction and everything, so that you may have much more laminar compared to turbulence. So you are going to use less force in order to achieve the same outcome, or you can use the excess force in order to become faster. Ni kajian biomekanik lah. Okay, so let's move on. We have right, this is motion of fluid. Okay, force in fluid motion most of the time can be divided into two. One is known as drag, another one is known as lift. Okay, satu ialah drag, satu ialah lift. Okay, drag can be defined as a force caused by the dynamic action of fluid. Drag force of a fluid act in the direction of the free stream fluid flow, and drag is also known as a resistant force. Resistance, friction, all of that is drag. Okay, this is the formula of drag. So later on you can actually observe this formula. Okay, and when we talk about drag, there are three distinct categories of drag. The first one is known as surface drag. Drag permukaan, friction pada permukaan. So drag derived from friction in adjacent layers of fluid near a body moving through the fluid. Bila kita bergerak, contohlah kita naik motor, you are going to feel that the air try to pull you back. That is surface drag. Okay, that is surface drag. All of those macam wind tunnel apa semua, itu semua untuk detect surface drag. Means if we have an object like this, okay, nampak tak object ni? Can you see this object? We throw this object in the air, there will be surface drag encompassing. Bola, okay, bola. Kita chest pass. We try to do a straight chest pass. However, dia tak pergi straight. Dia skewed kiri kanan, dia skewed ke bawah, naik ke atas. All of that is, some of that is caused by drag. Okay, 10 Newton, tapi hasil dia bukan 10, hasil dia 8. We lost 2 to surface drag. So surface drag is drag pada permukaan. So when we talk about performance in fluid condition, we are performed in surface drag. We are subjected to surface drag. Jadi kalau kita nak kurangkan surface drag, macam mana? Okay, saya bagi satu contoh. Kita main sukan equestrian. Okay, tak payahlah equestrian, susah sangat. Kita naik motor lah. Okay, kepada rakan-rakan lelaki yang pernah buat, boleh sumbang idea dekat sini. How we want to achieve maximum speed while riding a bike. Apa yang kamu selalu buat? Macam mana kita nak jadi laju? Cucuk angin tolak tepi dulu. Saya akan cerita cucuk angin sekejap lagi. Macam mana kita nak jadi laju masa naik basikal ataupun naik motor? What can you do in order to increase the speed? Silakan. Apa yang kamu boleh buat? What are the things that you always do in order to speed up? Dah habis pulas throttle ni, nak laju lagi. What can you do?
Jadi Superman je.
Jadi Superman. Baring atas motor. Okay, macam ni. Sekejap tu nama dia Superman ke Scorpion tu?
Superman je.
Superman Yamaha. Okay. So, let's observe this one. Kejap lagi kita KO. Ni ada lagi banyak jenis lah. Okay, let's see this one lah.
Assalamualaikum, salam sejahtera dan salam dua roda. Selamat datang ke channel Haris Fly. Channel apa? Haris Fly.
Berapa
Harap
viewer?
fly ke?
120,000 ke?
Video kali ni agak special dan berkait rapat dengan nama channel ni sendiri, iaitu Haris Fly. Tajuk video kita pada hari ini ialah 5
Okay.
yang ada dekat Malaysia ni. Yang pertama, Superman. Hahaha. Superman ni adalah jenis fly yang paling klise dan tipikal kat Malaysia ni. Kita selalu jumpa geng-geng Superman.
Okay, soalan saya. Based on what we have learned regarding drag, surface drag, regarding lamina, regarding turbulence, what actually happened pada Muhammad Haris ni bila dia buat penatang? Apa yang dia cuba capai? Okay. Surface drag dia macam ni. Ni angin datang pada depan kan. Langgar. Zah. That is surface drag. Drag that caused by two adjacent layers of air. So you are facing headwind. Headwind is surface drag. So by doing the first one, bila dia tunduk ni,
Dekat high
konon-konon dia akan dapat drag yang less because the air being moved through in top and circling rather than langgar badan-badan dia. Okay. Betul lagi dia ni.
way kat YouTube, kat Facebook, Instagram, TikTok. Fly to the moon. Bahasa Melayu dia terbang ke bulan. Korang agak-agak kenapa nama dia terbang ke bulan? Jeng. Nak tahu kenapa? Korang tengoklah sendiri. Tu nampak tu. Ini dia tidur sambil
Ini bengong.
macam kuntik. Nak
Yang ini kaki bergerak-gerak. Do you think it helps? Berbanding dengan yang pertama tadi. Bila dia angkat kaki, okay, the movement of air, thus dia akan ada turbulent, a lot of turbulent dekat sini. Okay, bila dia angkat kaki.
potong angin lah katakan. Yang keempat, katak fly. Wish, katak pun nak fly. Kalau korang tengok,
Okay, although dia tak angkat kaki ke atas, but now you need to remember when we talk about friction, it encompassing tadi tu kan, apa tu, Coanda effect tu, it encompassing. So kalau kaki ni sekejap terbuka, kejap tutup, kejap terbuka, kejap tutup, it hinder the airflow here. So it going to cut sometime. It going to increase sometime here. Okay, dia akan menyebabkan lamina flow tu kurang. You are going to get a lot of turbulence. Yang kelima apa? Gunting birama awak ramai-ramai. Okay. So that is some. Okay, that is some regarding surface drag. So you try to reduce surface drag. Okay. Now, cucuk angin. Okay. When we try to okay, katalah we ride a bike, so you are going to face a headwind. Lagi laju kamu bawa, lagi kuat headwind. And this headwind is going to plummet to all of your parts. Okay, sampai atas ni dia akan ada macam ni lah. And then towards the end, you are going to have a turbulence. Like I said earlier, if the shape is smaller, if the footprint of the shape is smaller, the turbulence is going to be small. If the footprint of the shape is higher, the turbulence is going to be a lot. Okay. So sekarang saya nak kamu tengok konsep ni. laminar flow, laminar flow, turbulent flow, and you have an area. I always call it an area of vacuum, tapi kamu boleh bernafas dalam ni. This area is where there are no flow of air inside that. Okay, and you're going to see betul-betul belakang that vacuum area, flow of air is actually pushing you forward. Alright, now let's go to cucuk angin. Let's say this is a lorry. We view this lorry transverse, means from top. Kita tengok daripada atas. And this is you riding your bike behind that lorry. Okay, so what is going to happen to this lorry? When this lorry move forward, it going to face a wind. Okay, and this wind will be deflected. Kanan, kiri, and also atas. It will be deflected to here. Okay, and around here, you're going to get a bit of, what we call it, turbulence. And there are some other air that move in the laminar flow towards the end. And here, you're going to get the most of the turbulence. If you're riding a bike, or if you're riding a car, okay, and you overtake a lorry or a bike, you are going to feel that there are some area here, bila kamu bawa nak motong kan, you are going to feel that you are being sucked towards the lorry. Katalah motor ni kan, dia rasa macam, tertarik ke lorry ya. Same go escalator, kamu akan rasa goyang. That is the area of the adjacent area of laminar and area of turbulence. Sampai sini susah nak lepas kadang-kadang. Bila nak potong kan, sampai area sini rasa berat sangat. Tapi bila lepas, you're going to feel lighter because you are out of that area. Okay, you are out of this turbulence and laminar area that pull you towards the side of the lorry. Okay, why you being pulled through the side of the lorry is simple. Natang ni. Different of pressure. Okay, if we have a lorry, we have an air moving through. Dekat sini, katalah kalau kita cerita partikel kat sini, there will be two type of pressure acted upon the system. Pressure out, pressure in. And most of the time, pressure in is larger than pressure out, which makes the object being feel like being pulled through near towards the larger object that in motion. Tu sebab bila kita nak potong lori, dekat sangat kamu akan rasa, tertarik ke lori, dah tarik sikit kereta pergi sebelah kanan. This is the reason why. Okay, now we want to talk about here. Okay, bontot lori. Kita besarkan, kita ambil bontot dia je, and then basikal, motor. How near cucuk angin will give you an effect. So based on computer simulation, based on computer simulation, the distance between the end of that lorry and the starting of your bike is 1 meter. Okay, means that this is the only area without any air. Sikit je area tu. Other than that, you are going to what we call it, you are going to be in an area of turbulence, either pushing forward turbulence or pulling backwards turbulence. And you are going to see if you are in this area, and also here, if you ride a bike, you are going to feel wobble, bergoyang sikit, because this is the area of the most turbulent being created, where the air from here and here, from right and left, start to mix. Mixing of left and right cause turbulence. Jadi kalau siapa nak cucuk angin tu, tengok motor, bat lori kat depan, cucuk angin, kereta pun boleh sumbat, kata kereta, van pun boleh sumbat antara kamu dengan lori. No, there is no effect. Okay, there is no effect. When you are in this area, when you are in this vacuum area, you are going to feel macam forceless. Lepas throttle pun, motor tetap pergi ke depan. You are not going to fall behind a lot. And when you pull on the throttle just a bit, you're going to feel that the bike is launching forward aggressively. Itu dalam kawasan cucuk angin. When you are out of that area, you are going to feel a bit of wobble. That is the area of transition. That is the area of turbulent. And when you start to feel stable again, you are out of any either turbulent or laminar flow of that particular car anymore. So siapa-siapa nak cucuk angin itu. And always remember 1 meter tu memang tak cukup untuk kamu brake. So please think carefully before you conduct any stupid action. Okay, itu surface drag. Number 2 is known as form drag, derived from a pressure difference between the lead and rear side of any moving body. Okay, form drag ni macam ni. Tadi kita cerita surface. Form drag, okay, motor lah. Kita ambil motor paling senang. Kereta ni pasal dia quite aerodynamics. Ini kereta. Kita ambil motor. Okay. I know that most of you have an history of riding a bike. When you ride a bike at quite a speed, there will be force from forward, and there will be some sort of laminar flow where at the end you're going to feel a bit of turbulence. Okay, soalan saya, when you ride a bike at a certain speed, can you feel a wobble at your rear tire? Bawa laju ni, lepas tu rasa macam ekor motor aku bergoyang lah. Pernah tak rasa benda macam tu? Okay, ataupun kawan kamu duduk belakang kan, you can actually see your member in front wobble. Dia bergoyang kiri kanan. Fish tailing. Fish tailing. Do you ever come across this particular situation? Those fish tailing. Pernah tak? Pernah kena benda tu? Anybody in the class? Have you ever in this situation? Motor laju ni rasa sedap, tapi belakang rasa macam tak ada atas tanah. You feel loose, you feel weightless kat bahagian belakang. That is wobble. And this wobble caused by different in term of pressure. Depan dan belakang. Okay, most of the time, in the front area, you are going to have quite high velocity of air, which make, when you have high velocity, the pressure is low. And towards the end, the velocity of air reduce. Velocity of air reduce, so the pressure at the back increase. This different in term of pressure causing a wobble. Left and right. It causes a wobble. And this wobble, this difference in term of drag, pressure from front and ends is known as form drag. Okay, is known as form drag. Kalau kita tengok daripada atas kan, if we observe the action from top, pergerakan ke sana, you are going to see something macam ni, pergerakan macam ni. Kalau kata, okay, kereta and then caravan attached. Kereta jalan tegak, but you are going to see caravan dia quite kiri kanan. Dia macam a bit of wobble, not much. A bit of wobble. It because of pressure. Pressure dekat belakang tinggi, pressure dekat depan rendah. Because velocity angin dekat depan tinggi, velocity angin dekat belakang rendah. This differentiation cause form drag. Okay, and this drag following a concept being proposed by Bernoulli. Bernoulli principle. Inilah dia nama dia, Bernoulli principle. When the velocity of at a certain place is high, the pressure is low. When the velocity is low, the pressure is high. Ini Bernoulli principle. Okay, and this Bernoulli principle can be described. Can be described by. I need to have. Okay, not this one. Okay, by this equation. Okay, P plus this one is known as rho. Okay, P plus rho V square 1 over 2 equals to C. Okay, if we further this equation, P plus rho V2 square over 2 equals to C. Means that if we take a look here, if we change P, V will change in order to maintain. Ni sama macam konsep angular momentum, sama macam konsep work, power and energy, where if PE tinggi, KE rendah. At the end, C tetap sama. If PE rendah, KE akan naik. So here, if the pressure is high, the velocity is low. If the pressure is low, the velocity is high. This is the concept of Bernoulli. Okay, in explaining the relationship between pressure and also what we call it, velocity of an object. Okay, to form drag. And finally, wave drag. Okay, wave drag ni kita kena rasa bila tempat tu ada ombak, ada wind. Drag derived from the generation of wave at the interface between two different fluid. Right. When you stand in the sea, okay, when you stand at the beach, and then the wave come towards you, you're going to feel that when the wave hit you, you're going to feel that you're going to push backwards. Itu wave drag. Okay, that is wave drag. Drag that caused by waving, by ombak, by benda yang bergelombang. Okay, so surface drag, drag that you can feel in between surface, means every single thing that move in fluid have surface drag. Form drag is the difference between front and back of an object which cause wobbling, and wave drag cause pushing and pulling by mechanical wave. So kita boleh nampak wave tu bergerak. That is type of drag. Okay, so kita ada 3 jenis drag lah. And then the second properties is lift, daya angkat. Okay, a force acting on a body in a fluid in a direction perpendicular to the fluid flow. Okay, first kita kena faham what does it means. If these are the perpendicular, these are the airflow. Okay, is these are the airflow, so lifting macam ni, lift. If these are the airflow, lifting macam tu. Ni masuk perpendicular. Okay, kamu akan dapat satu lifting effect yang sejajar dengan airflow. Kalau airflow dia macam ni ke bawah, airflow. So, lifting effect. Perpendicular. Okay, that is what we call tulis, lukis seorang-seorang. Okay, airflow. Again, airflow. So, perpendicular. Ke atas. Lifting effect. Airflow. Lifting effect. Itu maksud perpendicular lah. So you're going to have another another line which showing a lifting effect, which is sejajar dengan airflow. Okay, that is what it means by here. Okay, a force acting on a body in the fluid in the direction perpendicular to the fluid flow. Generally, a resistant force that tend to slow the motion of a moving through a fluid. Okay, when we talk about lifting effect, okay, when we talk about lifting effect, it has a lot in common with Bernoulli principle, with Coanda tadi. Okay, ni bentuk ni, angin yang bergerak. This is what we call an aerofoil. Okay, aerofoil is a shape where you have a flat at the bottom and you have semi-curve at the top. Okay, so if you take a look here, towards the end of the aerofoil, most of it is actually a very thin and pointy. It's because they try to reduce any turbulence. Okay, so by this aerofoil, what is going to happen is when an aeroplane move through the air, okay, angin ni dia akan langgar bahagian ni dulu. Okay, kita boleh bahagikan bahagian ni kepada beberapa lah. So this is the first place where the air will plummet, and then the air will move upwards, the air will move down. Okay, so bila dia langgar bahagian ini, dia akan naik pada atas bahagian. Bila yang bahagian bawah, dia akan lalu terus. Okay, so kenapa bahagian atas ni high velocity? Okay, contoh. Kita nak faham yang tu, kita tengok yang ni. Katalah kita ada satu salur getah. There will be water running in the salur getah. Okay. Now, my question is, what happen if we pinch salur getah ni? Jadi dia jadi macam ni. Air jadi lagi laju ke jadi perlahan? When we pinch the salur getah, what is going to happen to the velocity of the water out of this salur, of this pipe? Is it going to increase in terms of velocity or decrease in terms of velocity? If we pinch the salur getah, it will increase. Okay, it will increase. Same goes here. When the air move through the aerofoil, especially towards the top part, dia akan encompassing. Okay, dia akan membaluti Coanda effect. And to do so, it will pinch all those line of air, resulting much faster velocity of air at the top of the aerofoil compared to at the bottom where there are no obstruction. Jadi kita dah tahu tempat yang high velocity, the pressure will be low. Tempat yang low velocity, the pressure will be high. Okay, it can be further explained by this. In here, okay, let's say kita ada aerofoil tu. We have the aerofoil. Okay. And to talk about pressure, kita akan masukkan line of air. 1, 2, 3, 4, and towards yang atas, line of air dia tak terganggu. Same goes here. You'll get a bit then, and then become straight. Okay. Kalau kita namakan yang ini sebagai line nombor 1 lah, ATM. Okay. 1. Yang ini 2, ATM, atmospheric pressure. At 1 and 2, atmospheric pressure is equal. Okay, is equal. Alright, next. 2, 3, 4. Okay. Pressure here, okay, pressure number 4 is larger compared to pressure number 3, is larger compared to pressure number 2, is larger compared to pressure number 1. Means towards the aerofoil, the pressure increasing. Why? Because the speed decreasing compared to here lah. Yang atas ni pula, okay, kita namakan dia sebagai 4. Okay, ini will be 5, 6, 7, 8. Okay, kita abaikan satu ni lah. Okay, 5, 6, 7, 8. So here, pressure yang paling tinggi is 2. 2 is more than 5, is more than 6, is more than 7, is more than 8. Means that the 8 is the less pressure. Why? Because here the velocity is at the most. Okay. Jadi, kalau kita buat line of pressure dia macam ni. Ini yang paling tinggi. Ini yang paling rendah. Okay, this one is the lowest one. Jadi macam tu. So, movement of object in pressure, okay, pressure ni air particle, the way they move is they are going to move from low pressure to high pressure. Terbalik. Low pressure, high pressure pula. High pressure to low pressure. Tempat yang bertekanan tinggi ke tempat yang bertekanan rendah in order to stabilize. Jadi kalau kita ada satu objek dekat sini, it will move in this direction following pressure. Okay, following pressure from the highest pressure to the lowest pressure, and that cause what we known as lifting, daya angkatan. Ni yang kita dapat dekat aerofoil lah. Okay, why we have lift is because of the pressure. Tempat yang berkelajuan tinggi, pressure dia rendah. So this aerofoil, this wingspan of an aeroplane will move upwards. Jadi bila dia nak turun, apa yang dia akan buat? They are going to open up a flap. Okay, most of it is they are going to elongated dia punya wingspan and open up a flap so that this pressure at this velocity change. So now instead of high velocity at the top, it become high velocity at the bottom when they change the shape of the flight of the aeroplane. And when the shape change, the pressure change or switch place. Since atas dah jadi low velocity, pressure dia tinggi. Bawah dah jadi high velocity, pressure dia rendah. So, you are going to get turun. You are going to reduce the altitude. Ni Bernoulli principle. Okay, expression of the inverse relation between relative velocity and relative pressure. High pressure place, low velocity. Low pressure place, high velocity. Okay, and due to Bernoulli principle ni, okay, we are having Magnus effect, especially in sports. How can we go with a curved ball? How can we make a knuckle ball? Okay, bola tu baling ke bawah, naik ke atas. Bola sepak kita sepak tegak, but it goes to the left, it goes to the right. This is caused by Magnus effect. So Magnus effect is a deviation in the trajectory of a spinning object. So these are the two things you are going to observe. Satu, deviation. Dua, spinning. Okay. So keywords there is actually spin. So if you have a ball, you kick that ball and the ball does not spin, means you does not produce torque to the ball. This ball is going straight according to the force direction. But if you have a ball and you place a torque to the ball, which cause the ball to rotate. Okay, the ball is rotating. When this happen, you are going to get Magnus effect. Means you are going to get a deviation if the rotation is enough. If the rotation is not enough, nothing happen. This is what we call Magnus effect. Okay, ini apa yang kita panggil sebagai Magnus effect. For example, yang ini, kita baling bola ke depan and we rotate the ball counterclockwise. The effect is the ball is going to be turun. Dia akan curve. It is not going to be forward, but it's going to be curved downwards. Same goes if we spin the ball clockwise. Ni counterclockwise. If we spin the ball clockwise, what is going to happen is the ball is going to have a lifting effect. Dia akan naik ke atas. Same goes if we have a soccer ball, we kick the ball, cause the ball to have a clockwise rotation. So this ball with ample spin, it will deviate to the right hand side. And why it deviate to the right hand side? Because pressure here is low. Pressure here is high. This rotation cause velocity of air here low, velocity of air here higher. And the ball is going to curve. You're going to have a curved ball. Same goes if you apply torque to the ball, which cause the ball to rotate counterclockwise. So the ball is going to deviate to the left. Terbalikkanlah yang tadi. Kenapa dia deviate ke sini? Pasal pressure sini rendah. So pressure sebelah sini tinggi. Means that the velocity of air here is higher compared to the velocity of air here, according to the rotation. This is called Magnus effect. So what does Magnus effect tune? The difference of pressure between two sides. Okay, So the pressure, the higher pressure will move to the lower pressure. Ni yang terjadilah kat sini. Okay, kenapa dia naik ke atas? Okay, kenapa dia naik ke atas? Because atas pressure dia lebih rendah. So pressure move from relatively high pressure place to relatively low pressure in order to balance up the pressure. So Magnus effect result from a pressure differential created by a spinning body. So if the object that you throw does not spin, it won't get any Magnus effect. It will follow the direction of the force being applied. Bola rugby, okay, bola rugby selalu kita rotate dia kan. Bila kita toss dia forward, we tend to rotate the rugby ball. Bola rugby tossing forward, and at the same time it's rotate. So if the rotation is ample, you're going to see deviation of the ball from the trajectory, and this is known as Magnus. Okay, kenapa dia rotate kenapa dia pergi ke kanan? Senang. Pressure dekat bawah ni rendah, pressure dekat atas ni tinggi. So the ball is going to move that way. Okay, kalau kata bola tu kita rotate ke arah sana, means that if we rotate that way, the ball is going to have a deviation to the left hand side. Why? Because pressure here low, pressure here high. So the ball is going to deviate from the original line. It will deviate according to the difference in terms of pressure. This is Magnus effect. And this can only happen in fluid condition. So kalau kita buat benda ni dekat angkasa lepas, you are not going to see any deviation at all, simply because there are no pressure difference in those conditions. That is Magnus effect, and that is the end of our topic for today. So any question regarding movement in fluid condition? So we have drag, form drag, surface drag, wave drag, and then we have lift. Regarding Bernoulli principle, okay, Coanda effect, we have the difference of pressure from a different velocity of air, and that cause Magnus effect, which is deviation of trajectory based on the differentiation of pressure towards the system itself. So any question for today class? Ni konsep, hari ni kita belajar konsep. Ada soalan tak?
No, sir.
Okay. Alright. So if you don't have any question, this will serve as the end of our class. As for tomorrow, not tomorrow. As for Thursday tutorial, I'm going to prepare some question regarding angular impulse, angular momentum, and also for today topic buoyancy, pressure, and I'm going to have you to discuss that with your friend and come up with the solution. Besok hari Khamis nanti kita tengok. Tolong baca arahan dekat tutorial hari Khamis. Don't forget to take your attendance. Okay, right. So don't forget to take your attendance and use the time you have to start formulating your final presentation. The presentation need to be recorded and it need to be uploaded in YouTube before attach the link in the assessment later. Again, thank you for your participation. Assalamualaikum and very good morning to all.